Okay, so we're going to look at expanding and simplifying with brackets and a bit of factorising for algebraic manipulation. Just to remind you that if you are expanding brackets, then that word expand means multiply out. So for example, if I've got something like 3 brackets 2y plus 7, then it's telling me to do 3 times the 2y and the 7, and 3 times 2y is 6y, and 3 times 7 is 21. They're all positive because there's no negatives involved in this multiplication. So when we expand this bracket out, we'll get 6y plus 21. Now sometimes when you've got to expand, there could be an expression involving something like 3 plus 5 bracket 6x take away 2 take away 3 brackets 2x plus 7. So when we see something like this, then we've just got to be careful that we do things in the order of BIDMAS, and we think about doing the bracket parts first and then bringing this 3 in at the end and so forth. So for this one, if we think about this particular section here, then it's telling me to do 5 lots of 6x plus 5 lots of negative 2, take away 2. And if we think about this one, it's telling me to do negative 3, because we can think of this as a negative 3. It's lots of ways of thinking about this, but if we think of this as negative 3, so it's telling me to do negative 3 times 2x and plus negative 3 times 7. Now when we're working with negatives, quite often just think of those in brackets can help you to see what's going on, and then we've still got the 3 at the beginning to add in later. So if we go down the line, and it's worth doing workings out with this, guys, so don't be lazy and write out in full what you're doing. So we've got 5 times 6x, which is 30x. We've got 5 lots of negative 2, which is negative 10. And so we've got add negative 10. But when we add a negative, we get smaller. So we're basically going to say take away 10. We've then got negative 3 times 2x, which is negative 6x, so we can think of that as take away 6x. And then we've got negative 3 times 7, which is negative 21, so we've got add negative 21. But again, we're adding a negative, which means that we're going to end up getting smaller, so we end up taking away again. So now we've dealt with all the multiplications, we can now think of what comes together as like terms. So in this particular example, we've got 30x take away 6x, which is 24x, so that's dealt with that and that. It's take away 6x, and I've got a minus sign in front of it, so take away 6x. Then we've got 3 take away 10, take away 21. And again, just because it's got 2 negative signs there, 2 minus signs, does not make it a positive. It's got to be about following the operations carefully. So this is saying we're doing 3 take away 10, which gives me negative 7 so far. And we're then taking away 21 more, which will get me down to take away 28. So all of this brought together now is going to make this simplify to 24x take away 28. And that's what expanding and simplifying is about. Simplifying because we are writing things with less, so 30x take away 6x can be simplified to 24x. 24x take away 28 is as simple as we get. We can't bring the 28 and the 24 together because they're not all talking about x's, they've not got the same like terms. Okay, so that's just some background to what this topic's going to be about. So let's have a look at some questions, and then we'll do some more notes and things about factorising later. So this first question on the homework is asking you to expand and simplify with these 2 brackets here. So if we think of this first bracket, it's telling us to do 4 lots of each bit inside. So we've got 4 lots of p, which is 4p, and we've got 4 lots of 6, which is 24, but that was positive 6, so it's going to be positive 24. Here again, you've got to be careful. There's lots of ways of thinking about this, but usually a good idea is to think of this as negative 3 times that, which is going to be negative 3p, and then we've got negative 3 times positive 2, there's a plus in front of there, so we can think of it as positive. So negative 3 times positive 2 is negative 6. So just got to be careful, a negative times a positive creates a negative answer, so a takeaway answer. Then we think about bringing our like terms, so we can reorder this, keeping our signs with our numbers and letters to the right. So here we've got 4p's take away 3p's plus 24 take away 6. So if we finish simplifying that, then we've got 4p's take away 3p's, which is a single p. We don't write the 1 because 1p is equivalent to just a p, and we're trying to simplify as far as we can, so just write a p. And then we've got 24 take away 6, which will be 18, positive 18, so plus 18. Now in an ideal world we would check that this all worked. So the check would be to give p a number, so let's see what happens if we said p was worth 1. Okay, so the first bracket, let's just have a look what this says. It says that, take away 3 lots of p plus 2. So if we put 1 instead of the p, then we've got 1 plus 6, take away 3 lots of 1 plus 2. So we've got 4 times 7, take away 3 times 3. The bracket there gave me 7, the bracket there gave me 3. 28, take away 9 is going to be 19. And if I check my final answer, I can see that if I said, right, what happens when p is 1, then I've got 1 plus 18, which equals 19, same answer. So my check worked. So quite often it's useful to check whether you've made any mistakes with your minus signs, your takeaways and negative number multiplications. Okay, so that's the answer to the first one. So the next one is asking us to, again, multiply this bracket by 5. So 5 lots of 2q, 10q's, 5 lots of 3, 15. Again, we've got a p after here, so we've got to remember that that is going to give us this, and then we've got p following it. Then we can multiply this bracket out, so we've got take away 4 lots of p, and then we've got minus 4 times minus 1, negative 4 times negative 1, which makes plus 4, so just got to be careful with that double negative when we're multiplying. We get a positive answer there. Okay, so the p there has still got to be multiplied by each of the bits in here. So we've got 10q's times a p, so that gives me 10qp. We've got 15 times a p, so that gives me 15p. We've got take away 4p, and then we've got plus 4. So we go through looking for like terms. We've got no more we've got no more qp's, so it's going to be 10qp. Here though we have 15p's take away 4p's, which will be plus 11p. 15 take away 4 is 11, and talking about p's, so the answer will be p's. And then we've got plus 4, no other numbers on the row, no other constants, so it'll just be plus 4. So that would be the final answer for that one. This question then goes on and starts again practicing multiplying brackets out. So we've got 3 lots of everything inside here, so 3 lots of 2p is 6p. 3 lots of q is 3q, but we were doing take away q, so it's going to be take away 3q. We've got positive 2 times p, so that's plus 2p, and then we've got positive 2 times 2q, which is going to be 4q. Okay, so 2 times 2 is 4, we're talking about q's. Look for like terms, so we've got 6p's plus 2p's, and then we've got 4q's take away 3q's, so I'll leave us with just a q. So again, remember you can reorder to bring all the like terms together, keeping the signs with the term to the right, or the variable and numbers to the right. So we've got 6p plus 2p, and then we've got take away 3q's plus 4q's, and just then remember that these can be swapped, so it becomes 4q's take away 3q's. 4 take away 3 is the same as doing negative 3 add 4. You can swap around the order of operations as long as you keep the signs in the correct, or with the correct terms. So we've got 8p plus q from this, so the answer here 8p plus q. Okay, so this last question on this sheet has got 5p's plus 3q's take away the bracket. So again, thinking about BIDMAS and the order of operations, deal with things with brackets first. So we've still got the 5p plus 3q's, can't do anything with those at the moment, so let's get this bracket multiplied out. So it's saying 3 lots of p, but a minus in front of that, so that's going to be take away 3p. and then it's saying 3 lots of Q with a minus in front of it again, so 3 lots of Q. Bring our like terms together, so we've got 5P's, take away 3P's, and then we've got plus 3Q's, take away 3Q's, which is nothing, so the answer here will be just 2P. Okay. Okay, so the question goes on and talks about expanding with 2 brackets now. Now there are lots of techniques for doing 2 bracket multiplication. I use the grid just purely because it helps me to see what I'm laying out. So take the first bracket and write it out, and then take the second bracket and write it down the side. And it's a multiplication grid, so all I've got to do is remember that we are doing y times y, which will be y squared. I've left the plus 2 there, which was in this bracket, because I need to remember this is a positive number, so I'm doing positive 2 times y, which gives me positive 2y. I'm then doing positive 2 times negative 3, which gives me negative 6 there, because I've got positive times negative, negative answer. 2 times 3 is 6. And then I've got y times negative 3, which means I'm going to be taking away 3y, negative 3y. Again, with all these expressions, and I must simplify, so I bring my like terms together. So if I write out all my boxes, I've got y squared plus 2y, take away 3y's, take away 6. Here I can see that I've got no more y squareds in here to simplify any more y squared, so I'll still have that single y squared at the beginning. Then I've got 2y's, take away 3y's, which is negative 3y, and then I've got take away 6 on the end. So that's a reminder about how to expand those. Again, we've got a double bracket here, so we're doing a timesing because brackets next to each other automatically means multiply. And again, first bracket I can write down on the top row, and the second bracket I can write down on the side. So you just got to remember, keep the signs in the brackets with the numbers so that it helps you to remember whether you're doing positive or negative multiplications. So we've got z times z, which is z squared. We've got z times negative 4. Well, the z here is positive, so it's a positive times a negative, which makes it take away a negative sign. And then we've got 4 of them because we're doing z times 4. So it's 4z. We've then got negative 5 times z. Well, negative times positive again, so that's going to be a negative answer, and we've got 5z. And then we've got negative 5 times negative 4. Well, we need to remember that a negative times a negative is positive, so that's going to be plus 20. So write out what the brackets gave us inside the grid. So we've got z squared, take away 5z, take away 4z, plus 20. No more z squareds, so our answer will have a z squared in it. Here we've got negative 5z, take away 4 more z's, which will be negative 9z. Just remember here, just because there's 2 takeaway signs does not make it a positive, it depends on what's happening. So this is really saying you're starting at negative 5 on the number line, and the second there is the second minus there, our negative is telling you to take away, get smaller. So we end up down at negative 9. And then we've got plus 20, so positive 20 there. And here we've got w take away 6 squared. Well, we need to remember that this is equivalent to w take away 6 times w take away 6. The squaring telling us that we are multiplying the bracket by the bracket. And once we realise it's a 2 bracket multiplication again, then we end up with doing the multiplication. So first bracket along the top, second bracket down the side. Again, keeping the signs with the numbers to remind us that we're doing negatives or positive multiplications. This is a multiplication grid, so everything is multiplying. So w times w is w squared. Positive w times negative 6 is negative 6w. Negative 6 times positive w, negative 6w. Negative times negative, so positive here. So it's negative 6 times negative 6, which is positive 36. Bring together our terms, so we end up with w squared. We've got take away 6w, take away 6 more w's, so that's going to be take away 12 w's altogether, plus 36. Now, although we didn't show you checking in the previous ones, we'll show you how you check these with these ones. So I'm going to check with w equal to 8. I've chosen something bigger than 6, just so the brackets don't end up with negative numbers in them. So we end up with w equals 8 here. So the brackets at the beginning would have given me, replacing the w with 8, 8 take away 6, 8 take away 6, and 8 take away 6 is 2. Brackets next to each other means timesing. 8 take away 6 is 2, so we end up with an answer of 4. If I then put 8 into here, then 8 squared is 64. 12 eighths are 96, so we end up doing 64 take away 96 plus 36. Well, 64 plus 36 is 90, 100. 100 take away 96 is equal to 4. So our check work. Both ways we end up with an answer of 4 in the original brackets, and when we did the final multiplication and the expansion, then it still gave us the answer of 4. Okay, so just before we move on to factorising, just two quick notes about what factorising is to remind us. So factorise means put into brackets. Now we have to look at expressions and we have to think about what's going on. So if I have something like 3q squared plus 12q, then I can see here that both of these terms have common factors, things that will divide into and leave no remainder, so whole numbers and letters. So if I look at the 3 and 12 first, I can see that both of those divide by 3, so that would be what we call part of the highest common factor. It's the highest thing that goes into both 3, or the highest integer that goes into both of these 3 and 12. But then when I look at the letter parts of each term, I've got a q squared and a q, and both of these will divide by q, so I actually have a letter factor as well. Then I write a bracket. Now this time I only need a single bracket because both terms have common factors. So we need a single bracket as we have common factors to both, to all terms, because the expressions could be more than 2 terms. So when you have common factors to all terms in the expression, there'll definitely be a single bracket, because you can put the highest common factor on the outside and then divide the highest common factor into each term, and what's left goes inside. So if I think to myself, what do I multiply 3q by to give me 3q squared? Well, I need another q. 3 times 1, 3, q times q, q squared. Now I said 3 times 1, remember guys, because in front of that q, although we don't write it as mathematicians, there's a 1, there's one of those. So 3 times 1 is 3, and q times q is q squared. Plus sign, I want 3 times something to give me 12, well that's got to be 4, and then I want q times something to give me q, well it's q times 1, so I don't need to write anything else here, because 4 times 1 is 4. So that would be that particular expression factorised. Now what we notice is that this expression has q to the power 2. This makes it a quadratic expression. It has highest power 2 involved within the letter terms. So this is a quadratic. Now other quadratics, for example, if we had x squared and we had plus 12 on the end, plus 7x, so other quadratics like these, so again this is a quadratic expression, and we look at this and we say to ourselves, right, does it have common factors to all terms apart from 1? No. 1 will go into all of those, and that's the only factor that will go into all of those, so it doesn't actually change it. Could have said x, but x doesn't have anything to do with the 12, so there isn't an x common term, and the numbers themselves don't have a common factor other than 1. So this is actually going to be a 2-bracket factorisation. So this is a 2-bracket factorisation, as there are no common factors apart from 1. Okay, so when it's 2 brackets then, we put down our 2 brackets and we ask ourselves, because this is a single x squared, it's a unitary coefficient of x squared, then there's a fairly simple process goes on with these, and the 2 brackets would multiply out to give me x squared, so I'd have to have x times x to make x squared. The 2 numbers at the end have to multiply to make the 12. So I ask myself, what makes 12? Well, 3 times 4 would make 12, 6 times 2 would make 12, 12 times 1 would make 12, and technically negative 3 times negative 4 would make 12, positive 12. So I have lots of different ways that I could make the 12. But all I'm interested in is one of those ways has to add up to the middle coefficient. So it has to add up to the middle number here, which is plus 7. So this one here, if I take the two numbers I'm thinking would work, 3 plus 4 is actually 7, 6 plus 2 is 8, so that one won't work. 12 and 1, so 12 plus 1 is 13, doesn't work. Negative 3 plus negative 4 is negative 7, that doesn't work. So this is the only combination that would actually give me the two conditions I want. The two numbers multiplied to give me 12, because that's the end constant, and these are the two end numbers inside the bracket. And the two numbers also add up to the middle coefficient of 7. So in here we'd be putting x plus 3, x plus 4. Could have it the other way around, of course, remember, it could be x plus 4 and x plus 3. It doesn't really matter, because when we do our check and we actually then multiply out the two brackets to see what's going on and make sure it gives us what we want, then x times x is x squared, x times positive 4 is positive 4x, positive 3 times x is positive 3x, and positive 3 times positive 4 is positive 12. So when we add those together, we get x squared plus 3x plus 4x plus 12. Simplify our like terms, 3x plus 4x is 7x, and that gives us back what our original statement was, our original expression. So again, the checking is worth doing. So just a quick reminder, factorising when you've got expressions where there are common factors will be a single bracket, and factorising where you've got no common factors to all the terms will be a double bracket in GCSE exams, guys. Okay, so that's a reminder about factorising. So let's get back to the homework. So the homework goes on and talks about factorising these expressions. We look at this and we can see there is a common factor. Both of these terms divide by p, so that goes outside. Then we ask ourselves, what do I multiply p by to give me pq? Well, that would have to be q. And then what do I multiply p by to give me 5p? Well, that would have to be 5. So this one would factorise to p bracket q plus 5. Check by expanding, because that's the opposite of factorising. So p times q, pq, p times 5, 5p, positive, so positive 5p. Okay, so we look at this next expression and we can see that there's a b there, a b there and a b there. No other common factors, so it's going to be b on the outside, and then we ask ourselves, what do we multiply b to give us ab? We'll have to multiply by a plus c, take away 3. And then we check b times a, ab, b times c, bc, b times negative 3, negative 3b. Okay, so we look at this one and we can see that m goes into both of these, so not m squared, because this doesn't have a squared term, so it'll just be m as the highest power of m, from m squared and m. What do I multiply m by to give me m squared? Well, m. And what do I multiply m by to give me 3m? 3, positive 3, so we'll plus 3 there. This next one, I look at the two terms and I can see that n will go into both of these, so again it's going to be a single bracket factorisation. So n, no other highest power can go, so we don't have a squared there or a cube there. What do I multiply n by to give me n cubed? Well, that's n squared. What do I multiply n by to give me 2n? 2, and then I've got a minus, so minus 2. Okay, so that's a quick run through of the homework questions, guys. Hopefully it's of use.